All right, now let's practice this. So, what is the conjugate base for each of the following acids? So we're just going to practice writing out conjugate acid and base pairs. First, we'll take these acids and we'll write out conjugate bases, and then down here on the bottom half, we will take the conjugate. We'll write out the conjugate acid from these bases. So, if these are acids, what do acids do? Remember, they are proton, which is just an H plus, donors. So for something to be called an acid, that means it's going to give away a hydrogen. So we're going to draw this with one less hydrogen. Okay, we're going to take our initial molecule. The first one is HClO4, and we're going to draw it with one less hydrogen. So ClO4, and it's going to have a minus charge. Why is it going to have a minus charge? Well, if it started off neutral and it gives away a hydrogen, which carries a +1 charge, then what's left is going to have a minus charge. So ClO4, and it's very important that we don't forget the minus. It's not a complete answer. It's an incorrect answer unless you include the appropriate charge. So there's the conjugate base, ClO4 minus, for our acid HClO4. Okay, if we have an acid H2S, sulfur dihydrogen sulfide, and we want to, it's an acid, so it's going to donate a hydrogen. So we're going to draw this same molecule with one less hydrogen. So when we do that, we should get HS. Is it going to have a charge? Plus, neutral, minus. Well, over here, again, it's neutral. So when it gives away something with a positive charge, it has a negative charge, -1, because it gave away a plus charge. All right, so there is the conjugate base for H2S. The conjugate base is just HS minus. The third one, PH4 plus. So we're going to draw the conjugate base. Remember, if this is an acid, it's going to donate a hydrogen ion, so we're going to draw the same molecule with a one less hydrogen. So instead of PH4 plus, now it will be PH3. How will the charge be affected? Here, we're starting off with an acid that has a +1 charge. And when you give away a hydrogen, your charge always decreases by 1. The charge of the acid, I'm going to write this out. This is an important statement. The charge of the acid always, I need more space. Always decreases by 1, by a value of 1, as it becomes the conjugate, I'm going to abbreviate, base. The charge of the acid always decreases by 1 as it becomes the conjugate base. So if it was a +1 here, decrease it by 1, makes it neutral. We gave away a hydrogen. Now we have HCO3 minus. Draw the same molecule with one less hydrogen. So CO3, and take into account we have a -1. We're going to decrease it by 1. So -1 minus another 1 makes -2. And we gave away that H plus. So these are all the conjugate bases of these acids. Okay, now let's go to the bottom half of this slide. We have a bunch of bases, and we are going to write the conjugate acid for each one. So what is a base? A base is a proton acceptor. And I'm going to write a statement like I did up top. The charge of the base, capitals, always increases, opposite, by 1 as it becomes the conjugate acid. Okay, those are really important to note. So If this is going, all of these are bases, so they're all going to accept a hydrogen. So I'm going to draw the same molecule accepting a hydrogen. So we should have HCN. And let's read our statement again. The charge of the base always increases by 1. So if we started out negative, -1 plus 1 is neutral for this one. So that is our conjugate acid, HCN. Next base we have is SO4 2-. So we're going to add a hydrogen to it, hydrogen ion. So it's going to become HSO4. And if we had a -2 charge initially and it always increases by 1, we'll end up with a -1. So we went from -2 to -1. And notice I'm always writing that hydrogen out front, okay? Water. Water's our next base. We know water can accept a hydrogen. We've seen it done. What does it form? We had a special word for it. It forms H3O. It was neutral. If we add 1, it becomes a +1. We call this the hydronium. Hydronium ion, H3O+. And last base is HCO3-. So if we add a hydrogen to it, the conjugate acid is now 2CO3. It had a minus charge. How does the charge change? It increases by 1. So -1 plus 1, it's neutral. Okay, so we have just written all the conjugate acids for each of those bases. So that's something else I definitely want you to be able to do for the exam. Lastly, we are going to, this is a little bit more practice with just writing acid-base reactions and identifying conjugate acid-base pairs. Let's read this problem. It says the hydrogen sulfite ion HSO3- is amphiprotic. What does that mean? Something that is amphiprotic, it means can give or receive a hydrogen ion. It can act as an acid or a base. So part A says write an equation, a chemical reaction, in other words, for the reaction of HSO3- with water, in which the ion, which one's the ion? Is water an ion? No, water's not an ion. So in which HSO3- acts as an acid. So for part A, let's do that real quick. We're going to write an equation. So here's our two reactants, HSO3- plus water. And we want the ion to be the acid, so I'm going to label that. Here's our acid, which means water is our base. And what are we going to form? So now I'm getting you into the phase of you're going to also be able to, in some cases, write your products if you know what your acid and your base are. So if HSO3- is the acid, it's going to give away this hydrogen. The hydrogen is going to be given to water, and what's left over is SO3. Remember, the acid, let's go back up in here and read our statement. The charge of the acid always decreases by 1 as it becomes the conjugate base. So this is our conjugate base. And the charge was -1. It's going to decrease by 1, so it's going to become a -2. The base was water. It receives a hydrogen, so now instead of H2O, we have H3O. And let's read this statement. The charge of the base always increases by 1 as it becomes the conjugate acid. So if this is the conjugate acid, it went from neutral, it increases by 1, it becomes +1. All right, so that's part A. Part B, here's part B. It says write an equation for the reaction of HSO3- with water. So same reactants, let's go ahead and write those out. HSO3- with water. But this time we want the ion to act as the base. So let's label the ion as the base, and water is the acid. So now what products are we going to get? Well, we know an acid donates H plus. This is going to receive H plus or accept it. So one of these hydrogens is going to come over here. So we will get, instead of, let's write the conjugate base first. So if the acid, which is water, donates an H plus, what is left over? After water gives away an H plus, what is left over? We will have HO. But we don't write it like that. You always write you'll have OH minus, hydroxide ion. Okay? Remember, the conjugate base always has a charge that has decreased by 1. So here it was neutral, and here it's a -1. And this is the conjugate base of the acid, water. Plus, okay, the base, HSO3 minus, receives a hydrogen. So now instead of HSO3 minus, it's H2SO3. And remember that the charge of the base up here always increases by 1 as it becomes the conjugate acid. So if we had a -1 charge over here and it increases by 1, it's neutral. Charge of 0. And this is the conjugate acid. So if we were to draw in a black line connecting the base to the conjugate acid, we would do it like this. And if we were to draw in a different colored line, oh, let's do bright green connecting the acid and the conjugate base, it would look like this. Okay. All right. I think that gets us to a pretty good